Hey there. So today we're going to talk about analysis of variance, contrast, and effect size. So according to our question, we have our questionnaire about healthy eating habits. So we have the data that was in the original question. Using the alpha equal to 0.05 significance level, is there a difference in healthy eating habits among the professionals in the three sports? So we're going to look at the test, the actual test itself. We will look at effect size. We're going to look at planned contrast, and we're going to conduct a Scheffé's test. So what we want to do, as mentioned, we want to use our one-way analysis of variance, that is ANOVA, for the three types. So we're going to be using the R programming language. So here is what you're going to put in there. So I've got my data frame with the factors and the data values. And then I construct an analysis of variance using X as a function of type using the athlete.data frame. So we look at our summary and we've got our type, we've got our residuals, our F value is the 2.351, while the probability of greater than the F is 0.151. All right, so the test of hypotheses is going to be mu sub mu sub A equal to mu sub B equal to mu sub C versus not all of the means are equal. So our test statistic, depending on how your question is phrased, if you're going to use the F value, that is the F star, that's your 2.351. If you're going to use p-value, that will be the 0.151. All right, so the rejection region, again, it's going to depend on which of the test statistics you're going to use. If you're using the F star, you want to compare that against F at with 9 degrees of freedom at alpha 0.05. That will get you to 4.256. So your rejection region would be set up as if the F star is greater than 4.256, then we reject the null. If you're going to use the p-value, the statement is if p is less than 0.05, then we reject. And then the final step will be, since the F star is less than the 4.256, we will fail to reject. If you use the other method, since p of 0.151 is greater than alpha of 0.05, we fail to reject. All right, so we're going to use our Scheffé test. We're going to install the DESC tools package. So here are your steps. It'll take it a little while to load up that DESC. There's a lot of packages. Okay, so you're going to actually use the function called Scheffé test on our model. Okay, and those are your post hoc multiple comparisons. So you're going to be looking at these. You're going to see the different p-values. So not surprisingly, all of these p-values are large because, why is it not a surprise? We failed to reject on the overall test. Therefore, none of the original two-piece statements will be different, or I should say, we'll have a low p-value. Okay, finally, the effect size. This takes a ton of time, bringing all kind of stuff in. So you're going to have the library effect size. You're going to use something called eta square on that model 1, and the partial is true. So when you look at the result, it comes out to 0.34. So that's pretty close to your medium range when you go back and look at the definitions from the Cohen setup. And then finally, for the planned contrast, I typically use the Bonferroni. Again, you could actually use the Scheffé in this one. But anyhow, let's take a quick look. So what this is doing, you're going to take that, break out that data frame into pieces. And the adjustment you're going to use is the Bonferroni. It's going to take 2 at a time. And you're going to get a p-value for those. So essentially the A and the B are 1, and then the A and C is 0.26, the B to C is 0.30. Again, none of those are less than the 0.05. All right, hope this helps. Bye.